Electez Design Suite, EDS, is electrical and instrumentation design software. It has three main modules, and this is a demonstration of the Instrument Manager module. Instrument Manager is a database-centric application which can maximize efficiencies in the production of the drawings and reports required in instrumentation design. Instrument Manager uses a SQL database to manage and produce deliverables such as loops, datasheets, hookups, wiring diagrams, schematics and reports. Electez is a tool used by electrical designers to produce 2D circuit diagrams such as schematics, single line diagrams, wiring diagrams and 2D panel layout. PanelDes Raceway is a tool used by electrical designers and engineers to model 3D plant, electrical and raceway systems and to do cable routing and fill calculations. Electez Design Suite has been developed for over 30 years, covers multiple languages and has been used in more than 50 countries. Electez Design Suite has libraries in IEC, ISA, IEEE, ANSI, NEMA, AS, JIC, DIN, BS and has been licensed to over 15,000 users. This shows just a few of the EDS customers. Back to Instrument Manager. Instrument Manager has been designed around a data-centric, flexible philosophy, i.e. generating diagrams from a database. Databases allow a team to use components-based data, enhancing accuracy and ease of management. Databases enable us to deliver a cloud solution. For flexibility, we use templates or typicals for all deliverables. From datasheets to loops, your company can choose exactly how your deliverables look. Instrument Manager integrates tightly with the other modules of EDS, allowing instant access to bespoke diagrams in Electez, plus 3D modeling and cable routing. Productivity. Instrument Manager can be live linked to P&ID SQL databases or import from a number of sources such as SQL, Excel or Access. This integration lessens the chances of errors, double handling and rework. The component-specific database structure allows for the fast data entry and efficient correction tools such as find, replace and catalog selection of a dataset. Needless to say, the mass production of loops, datasheets, hookups, wiring diagrams and reports without CAD drafting represents productivity rarely seen. Instrument Manager increases the quality of your deliverables. The single database ensures data consistency and easy verification of your design. To add to that, template or typical based mass generation ensures that if one of your deliverables is accurate, then so are the other clones. Instrument Manager allows you to manage your data in an intuitive tree and folder environment with each component's properties visible via list views. Your admin can choose Access or SQL Server, can add database tables and add columns. Authorization levels for user access are provided for your security needs. Instrument Manager also provides easy exports, a design issue forum, and user-defined components, logging, and a data testing highlighting system. Instrument Manager is a true multi-user concurrent engineering system. Instrument Manager can mass produce the following diagrams, all in DWG format: loop diagrams, hookup diagrams, wiring diagrams, terminal strip diagrams, schematics, elementaries, I/O card diagrams. Instrument Manager can produce a number of automated reports including bill of materials, conductor schedules and an instrument index. I will provide more detail on these reports later in the demo. For the remainder of the demo, we will be doing the following: building components in the database, connecting the components to conductors, linking the components that are related, creating deliverables such as loops, datasheets and reports, and informing you about the features and benefits of Instrument Manager. Before I start making components, I will briefly describe the simple instrumentation system I will create today. This will assist you in understanding the Instrument Manager workflow. From this diagram, you will see that I have 8 instruments, 4 flow transmitters and 4 conductivity sensors in 2 different areas, Field 1 and Field 2. In each area I will have a junction box, JB1 and JB2. These junction boxes will contain terminal strips, XJB1 and XJB2. The instruments connect to these JBs. From each junction box, a cable will run to a terminal strip, XCR1, in a marshalling panel, MP1, in the control room. There will also be a PLC cabinet in the control room, DCS1, and inside this I will place an 8-input analog I/O card. I will connect wires from the marshalling cabinet to this card. After connecting wires and cables to devices and terminals, I will show the deliverables output, such as loops and datasheets for these components. The system I have described will give you an idea of the workflow in an Instrument Manager project. However, there will be other components in my project that I will use to show you other Instrument Manager features and deliverables. For familiarity, I will firstly give you a quick tour around the Instrument Manager user interface. The user interface is easy to use and intuitive. The first thing to note about the user interface is the tree control on the left side. This allows you to navigate around your project. You can work on your project's components, output diagrams, templates, cable routing, and other facets. We are interested in components first, so I will open up the Motors folder from the Devices branch of the tree. The right side of the screen contains the list views associated with the current tree selection. The top list contains the components in the folder, and the lower list contains the ratings data for those components. With the components in the list view, you can select a specification from the catalogue, add a datasheet or loop, and globally edit components. If I click on the toolbar button displaying the pencil, I can switch to an edit view. The edit view allows you to do basic editing commands on one or more components. These views can be sorted and filtered using the title bar. I can simply type a tag name change and the database will ensure that the tag is propagated to all the places that it is used, a big advantage over working with Excel. The edit view also contains many advanced electrical functions that you will not find in basic spreadsheets. You can, for example, execute cut, copy and paste commands, doing surgical inserts and removals in a designated part of a column of data or tags. Incrementing values by sequence and replacing bulk data with a file of replacements are both very useful in the instrumentation and electrical disciplines. If I click the toolbar button displaying the blue connection icon, I can see a connection view. The connection view has 3 component trees that allow you to drag and drop components onto each other, and that creates connections. Below that, we see a connection preview window, currently showing a terminal strip and its connections. When I select an instrument, the preview window traces the instrument signal circuit and previews the loop for the instrument. When I select a cable, the preview window displays all of the cable cores and the terminations on that cable. I will now return to the list view and create some components. With Instrument Manager, there are multiple ways to build your project, starting with manual component creation. Firstly, I will select the Areas folder. Then I will use the Add function from the right button menu to create myself a new area. My areas will be named Field 1 and Field 2. I can make these in a single operation by setting the first tag name in the area builder and the number of areas to be 2. My 2 new areas are displayed. Now I will create some enclosures. I will select the Enclosures branch and the Enclosures folder. I will use the Add function to create 2 junction box enclosures. My junction boxes will be named JB1 and JB2. I can make these in a single operation. Junction boxes have many electrical specifications. I will select the specifications from the EDS catalogues. I will select the Hoffman manufacturer and choose a hinged cover galvanised box. The EDS catalogues are customisable. You can add your own manufacturers and part numbers. You can also add as many specification columns as you wish. I will set the number of enclosures to be 2. My 2 new junction boxes will be displayed. Now I will create some terminal strips for my junction boxes. I will select the terminal strips branch and the terminal strips folder. I will use the add function to create 2 terminal strips. My terminal strips will be named XJB1 and XJB2. I will select the terminal from the EDS catalogues. I will select an AB1 series terminal. I will set the number of terminal strips to be 2. I must also set the number of terminals in each strip. In this case, I have set this to 30 terminals. My 2 new terminal strips will be displayed. I can quickly parent the terminal strips inside my new junction boxes. I will now create some instruments. I will create some flow transmitters in the Instruments branch and the Anybar flow meters folder. Again, I will use the add function to display the builder. My flow transmitters will be named FT001 through FT004. From the EDS catalogues, I will choose a generic sample part provided. In this sample, we have configured a default cable to use with new inserts. I will set the number of instruments to be 4. Instruments are configured to offer to add and link a new default datasheet, loop, and a new hookup diagram when created. I will accept the offer. My 4 new instruments will be displayed. I will now take a closer look at FT001. Note that there is a cable created and connected to the instrument. The cable cores are terminated to the instrument terminals. I will now create 4 conductivity sensors. This time, I will filter the catalogue to find the part by description. I can simply type in the first few characters. I will again choose a generic sample part from the catalogue. I need 4 conductivity sensors. I will confirm that I want a new datasheet, a new loop, and a new hookup diagram. My 4 new conductivity sensors will be displayed. I will now create an 8-input analog PLC I/O card. As you would expect, this has a more complicated builder than the other components. However, the process is still quite similar. Firstly, I will select the card part number from the catalogue. The PT config and the PT term list fields define the structure of the cards. The card I want is an 8-input analog card. I will now give my card a tag name. I will now set the start address, rack and slot for my card. I/O cards can have descriptions loaded for each I/O. These can be pasted from your PLC programming system. My card will now be displayed. Instrument Manager has the capability to import and export data from and to many other sources, including static spreadsheets and other databases. Instrument Manager may be live linked to an existing P&ID database, and data can be shared for instruments as well as associated components such as tanks, lines, valves, and other equipment. We can link to any P&ID database hosted on SQL Server, including CADWorks, AutoCAD P&ID, and SmartPlant P&ID. We have a mapping system and an alias system whereby we map field names in an external database or spreadsheet to fields required in Instrument Manager. In my database, I have 15 or so valves, and 4 are live linked to a P&ID project. All components imported from a P&ID live link have a P&ID stamp on their icon. They will also carry linking data and typically spec data that is sourced from the P&ID. As well as instruments and valves, I have equipment from the P&ID linked. I have 3 tanks linked. These will be associated with the instrument I am working on and will provide process data for the instrument data sheets, etc. I have 30 or so lines linked. These will also be associated with the instruments I am working on in order to provide process data. The importing system is highly flexible and is very likely to cater for your importing needs. However, in the worst case scenario, if you have an unfriendly data source, Excel can be used as an intermediate step in capturing your external data. We'll need to add 24 wires to connect between the PLC and the marshalling terminal strip. I will select the wires branch and the wires folder. I will use the add function to create a batch of wires. The first wire will be WMP1001 and the others will be sequenced up from there. Wires and cables have many electrical specifications. I will select the specifications from the EDS catalogues. I will set the number of wires to be 24. My new wires will be displayed. While we have already added cables for the instruments, due to a default cable being catalogue defined, we still need to add a couple of extra multi-core cables. These multi-core cables run from the marshalling panel to the junction boxes. I will add the cables to the Cables to JBs folder. The 2 cables will be named CJB1 and CJB2. I will select the specifications from the EDS catalogues. My cables will each contain 8 screen pairs. My new cables will be displayed. The cables will contain the appropriate numbers of cores and every conductor will be named as per the catalogue spec. These cables are smart. They contain all of the specification data required for termination and later cable routing and tray filling. Next, we will move to the connection view to electrically connect cables and wires to instrument, device and junction box terminals that I have created. Firstly, I will explain the connection view. It contains 3 tree views used for dragging and dropping conductors to make connections. Under the trees, there is a circuit preview window that previews your components' connections. The preview window will by default try to display a loop preview for any component that is highlighted. It traces a signal to its endpoints to derive a loop. If I select a cable, then I will see a cable preview. This includes the cable's conductors and any terminations on the cable. Similarly, if I select a terminal strip, then I will see a terminal strip preview. This includes all of the terminal strip's terminals and any conductors connected. We can use these views to track the progress of our termination process. I will firstly set the trees up to expose the multi-core cables and the junction box terminals so I can connect these together easily. When terminating multiple conductors, in my case 25 cores of a cable, I need to only select the top terminal and drop the cable onto this. Instrument Manager asks me to confirm the terminals on the strip that I wish to use. In my case, I will simply connect to the first 25 terminals. After I confirm the connections, I can see them in the cable preview. I will now connect the other end of the multi-core cable by dropping it on the first terminal of the marshalling panel, MP1. I am again asked to confirm the terminals to connect to. After I confirm the connections, I can see these in the cable preview. The cable now has both ends terminated. I will now repeat the process with the second multi-core cable, CJB2. This must be connected to the second junction box, JB2. The second end of CJB2 is also using the marshalling panel MP1. However, this time we need to start terminating the conductors on terminal 26. Just a quick note, it is obviously also okay to connect a single conductor to a single terminal with drag and drop. Cables CJB1 and CJB2 are now both fully terminated. When I created my 8 instruments, Instrument Manager also created and terminated a single pair cable on each instrument, as required by the catalogue. These cables have not been connected to anything yet. The loop preview for my instruments looks a little incomplete. In this next phase of connection, I will drop each one of these instrument field cables onto its respective junction box terminals. I will drop the cables on the desired terminal in the junction box, then check and confirm that I am connected through to the correct conductors of the multi-core. As I am doing this, I can see the junction box terminal strip is gradually becoming populated on each side, indicating I have a through connection. I will now take a quick look at the loop preview for my new instruments. The loops are looking a lot more complete now that I have the junction box and the marshalling panel connected. I will open up the I/O card I created earlier and inspect the terminals. There is one more set of connections required to complete my loops. I need to connect the wiring from the marshalling panel to the PLC I/O card. Wires are easier to terminate in bulk using the list view. With the list view, I can select multiple wires and drop them onto the target terminals. I can choose the top terminal, then choose to paste sequentially. This connects the wires to terminals in sequence with their tree position. Again, you can make these terminations individually if you wish. The other end of these wires is connected to the marshalling panel terminals. I will connect these 3 wires at a time, selectively cross-wiring them to the desired instrument. I will now preview my loops. With the red wires now present, they look complete. With Instrument Manager, we can associate or link items. What I mean by link is to bind 2 components or database items together for easy access and navigation. A simple example is parenting or containment links. For example, we might place terminal strips in their parent panels, panels into a parent area, or instruments into areas, etc. Linking allows an Instrument Manager document or diagram to contain data from a primary instrument and data from components the instrument is linked to. On screen I have 2 areas displayed, Field 1 and Field 2. I will now parent 2 of my new flow transmitters in each area. Typically, we drag and drop components to make a database link. However, many components can be automatically contained or associated when importing data. Terminals and cores are automatically parented by terminal strips, devices and cables when those parent components are created. I will now also parent the new conductivity sensors into each area. Once linked with parenting, the user interface shows the children underneath the parent in the tree. Also, the children are listed on the right side of the user interface. There are other non-parent links we call association. Associating the lines with my new flow transmitters allows me to reference the line data in the instrument's output datasheets, reports and diagrams. Associating is also a drag and drop operation. An instrument can automatically inherit the spec data of its associated pipe, tank, etc. You can also associate other documents with the project's components, such as PDF service histories, photos, and test sheets. When a component has links, you can use the right button menu to navigate between those links. I will now navigate to this instrument's loop diagram. Output diagrams and other deliverables are linked to their instruments. It is easy to change the links between output diagrams and datasheets and their instruments. Instrument Manager and its deliverables, such as datasheets and loops, are easily customizable, letting you do things your way as opposed to ours. As an example, let's have a look at one of the sample templates from which the output datasheets are generated. These are in the Templates branch of the tree. Templates are fully customizable in terms of appearance and content. A template typically has three types of content. The first is the background graphics, such as the logos and diagrams. These don't change on a new datasheet. The second is the fixed text, such as the titles and legends. These also don't change on the new datasheet. The active part of the datasheet, that changes with every new sheet, is called a formula. Formulae are enclosed in two hashtags and are easily recognized. I will add a formula hashtag R1 service hashtag to the H11 cell. The R1 links the data to the instrument's ratings record, and service is the column name in that record. I will also change the background graphic to yellow. This is simple Excel editing. Saving the template is all I need to do to complete my simple customization of adding a new column and changing the background graphic. I will now open up the Output Diagrams folder and look at the output datasheets that use the customized templates. My new flow transmitters use the customized template. These datasheets were created and linked when I created the instruments. Note, it is possible to link several instruments to one datasheet. However, by default, there is only one linked. I will now generate the datasheet for FT001. There is now a new Excel file in the project. Similarly, I can select several output datasheet records and, in one operation, generate multiple Excel datasheet files. While we are awaiting the generation, I will just mention a couple of useful facts about template-based generation. Firstly, we provide a column picker for automatically inserting formulae for columns in any of the tables linked to the instrument. Secondly, each instrument folder has its own default datasheet and other templates. I will now show you how we can add data to the completed Excel-based datasheets and then re-import the data to our system. We call it form editing. This is useful for computing manufacturer or supplier field data without retyping it. I will simply fill in the service cell with a description of the instrument's service. I will now save the file and exit. Instrument Manager will scan the file for changes and will then ask me if I want to re-import the changes detected. I can now see the changes made to the instrument within the Instrument Manager list view. Once I have the data from the form edit, I can replicate it to other similar instruments in my system. In this case, I will simply copy and paste. I will now open up the Output Diagrams folder again and regenerate the output datasheets to examine the changes. Regenerating all of the flow transmitted datasheets will take a few seconds. The final deliverable datasheets are highly flexible and extremely portable. These Excel datasheets can be viewed by anyone with a computer. As you can see, the service data I entered is now displayed in multiple places on the datasheet, and the datasheet background has been customized. As a final note on datasheets, they can be multi-page documents for a single instrument. They can also be multi-page documents for multiple instruments. Our hookup diagrams, otherwise known as installation detail drawings, are generated from customizable templates. Let's have a quick look at one of the flow transmitter hookup templates. These are in the templates branch of the tree. Hookup templates are DWG files and are fully customizable in terms of appearance and content. The background CAD diagram is 100% your choice. You will see on the hookup template that there are many hashtag enclosed formulae, including tagging data and title block data. Hookup diagrams contain intelligent, quantified material tables which integrate with your reporting. I won't make any changes to this template. My new flow transmitters use the template we just viewed. The output diagram records were created and linked when I created the instruments. I will navigate to the Hookups folder in the Output Diagrams branch. I will select the hookup records that were created for my 8 new instruments. I will now generate the 8 hookups. There is now 8 new CAD files in the project. Now I will view the hookup for flow transmitter FT001. As you can see, the formulae are now gone and the tagging and title block information have been loaded from the database. As a final note, each instrument folder is linked to its own default hookup diagram, enhancing your efficiency and accuracy. Instrument Manager provides 3 different types of loop diagram: auto loops, custom loops, and field bus auto loops. Auto loops and field bus loops use a Lego building block style of construction, with many small template blocks arranged parametrically to form the loop. The loop preview diagram, displayed in the connection view, mimics the default auto loop that will be drawn for an instrument. The preview displayed now shows the auto loop preview for my new flow transmitter, FT001. Auto loop output diagrams are, by default, found in the Loops subfolder of the Output Diagrams branch of the tree. I can individually generate the auto loop for FT001. Generation includes a template background border and 1 or more parametrically arranged loops. I can also generate many auto loops in one operation. Typically, Instrument Manager can assemble 3 or 4 loop diagrams each second. I will select the loop records that were created when I built my 8 new instruments. In a few seconds, I have created 8 new CAD files in the project. Now I will view the loop for flow transmitter FT001. Auto loops are highly automated. However, like Lego, they are modular and digitized. When your loops need bespoke diagrams, you may need custom loops. On this simple loop, it is obvious that it has been created with many small modules. For example, the yellow terminals are modules and so are the cable markers. It is possible to change the modules for each component type and also the spacing and positioning. However, this flexibility does not suit every circuit diagram. In summary, auto loops are highly automated. However, they are modular and digitized. When your loops need a bespoke diagram, you may need custom loops. I will now set the FT001 diagram to have multiple instruments. I will now generate the auto loop for FT001 again. When I view the loop, I can see that any common devices and cables from the 3 loops have been merged together. For example, the junction box JB1 is merged for all 3 loops, and also the multi-core cable connected to JB1. The marshalling terminal strip and the I/O card are also drawn as a single component. Note, if you add another loop to the diagram that does not share terminal strips or devices, then it will be drawn separately without merging. A field bus loop is a special type of auto loop which arranges a Lego-style diagram around a field-located hub device. The circuit consists of the central hub, hub 6, with multiple instruments on the field side of the hub. On the network side of the hub, there is a chain of other hubs leading back to an I/O card. In this example, you can see that the components and the layout are similar in content, appearance, and spacing to the auto loops we looked at earlier. This diagram is also highly automated but modular. Custom loops are generated from fully customizable templates and sub-templates. Custom loops are highly flexible. They can have any content and appearance. For example, the background CAD diagram is 100% your choice. From this diagram, you can see that the final diagram contains a master template, which contains the I/O card and the marshalling strip, and 6 sub-templates, each representing one of the 6 control valves that are on the 8-point analog output card. Each master and each subloop contain their own linked database data. The data on each custom loop is typically derived from one or more instruments and/or devices and their related components. Custom loops are infinitely flexible in appearance, however they require a little more engineering to configure and create when compared to auto loops. Terminal strip diagrams, otherwise known as wiring diagrams, are generated from our EDS wiring diagram generator plus a customizable border template. There are often multiple components on a terminal strip diagram, perhaps 2 terminal strips in a junction box or similar. In my case, I have 1 terminal strip and 4 instruments in each diagram. I will now generate the 2 terminal strips. There are now 8 new CAD files in the project. Note, to set up a terminal strip diagram with a base template only, we can simply accept the defaults when creating the terminal strip component. The base template typically only contains the border, so we must also enter a position for that terminal strip on the template. I will now view one of the terminal strip diagrams I have generated. The border and title block have been loaded from the base template. The EDS wiring diagram generator builds components in a Lego style. Terminals and wire markers are made from a small template symbol. The instruments are positioned to the left of the terminal strip. Each instrument can have its own wiring diagram template symbol, your choice of graphic. Where practical, cables are drawn between any connected components on the diagram. All base template formulae, including the title block formulae, have been loaded from the diagram record within the database. We will now generate some reports from IM. All reports use templates which you can customize. These can be customized with a point-and-click editor and zero programming. Firstly, I will generate a single report, the instrument index. This is an internally configured instrument manager report detailing the project instruments. Now I will generate the EDS reports. The EDS reports include a project-wide materials list, several conductor and connection reports, and many others. The internally configured Instrument Manager reports can be set up from the main menu of Instrument Manager. Instrument Manager creates a set of report tables within the project database. These tables contain the raw data for all of the reports. I will select the Bill of Materials report data table. In this table we can see the manufacturer, part number, and tag names of the components in our project. The next table I will examine is the Bill of Materials Summary Report data table. This quantifies the components listed in the Bill of Materials report. The report tables are all derived from a template and can contain user-defined columns and column sizes. I will now examine the cable schedule report tables. This contains the cables in the project, their from and to terminations, and loads of rating data. The cable schedule typically contains the data required for cable routing. Don't forget the EDS reports contain components from all EDS modules. The instrument index details the project instruments. This can contain your choice of the instrument data and also as much related component data as you wish. For example, the PLC I/O address for the instrument and the process line data are linked to the instrument and hence can be included in the report. The PLC index details every I/O used by the PLC or DCS in your project. This is another report internal to Instrument Manager and can contain data from any component related to the PLC I/O. The last table I will browse is the wire schedule table. This contains the wires in the project, their from and to terminations, and wire rating data. I will now show you a few of the formatted reports. The formatted reports in this project are located in the SQL Server Report Services. I have chosen to have my reports viewed in a web browser. The first report I will view is the cable list, sorted by type. This groups the cables by part number and therefore by specification. The from and to, enclosure and device data is included in this report, as well as the cable spec data. I will now inspect the cable core list, sorted by destination enclosure or area. This lists all cable cores, otherwise known as cable conductors, and the terminals that they are connected to. This data could be used to terminate a cable. Note that the format of these reports is completely customizable without programming. You can change the look or the content by pointing and clicking. I will now inspect the PLC card list. This, as the name suggests, lists every PLC I/O card in my project. I will now inspect the PLC I/O list. We viewed the unformatted table for this earlier. I/O descriptions and address details feature in my report. I will now inspect a materials list. I have multiple materials lists with different sorts and groupings applied. Just a quick reminder, EDS reports can have pretty much any content, any sorts or grouping, and any format and graphics. When a project is underway, there is a high value in tracing data events as they occur. This way, it is easy to trace the source of problems should one exist. Instrument Manager has a programmable event log which traces the project database activity during your project. In the event log query, you can see each data event, for example, items added, deleted or modified, and which table changed. As you would expect, the time and date is also logged, and similarly, which computer and user caused the event. In the preferences, there is a page where you can preset the events that will be logged and the components they will be logged for. For example, you can log the events where a user logged on or off, or specifically when a cable was added to the database. Similarly, you could log an event when a datasheet was generated, a connection made to a wire, or a revision was changed. Instrument Manager also has a smart system for detecting data that is out of range or otherwise special and highlighting that data. I will start the Highlights editor to show you an example. In this example, any instrument in the Flow Meters folder which has a service mentioning the word gas will be highlighted with red text. It is also possible to filter by the date, change the background color, and use complex data filtering conditions. I will now check my Flow Meters folder. As we can see, the first three instruments mention gas in their service column, and the final instrument mentions water. It is useful to note that the selection tool overrides the highlighting color. We will now have a quick look at the Project and Revision Change system within the Preferences. From the Project tab in the Preferences, you can change the current project revision. This will cause project backup to occur and will adjust the title block fields that are tied to or loaded with the revision setting. You can also manage the EDS project sync when opening and closing Instrument Manager. There are two other modules in the EDS suite of tools, Elementaries and Elementaries. Elementaries is a 2D design package for developing electrical circuits. Elementaries produced 2D circuits are included directly in the Instrument Manager project. Elementaries components will appear in the folders such as motors and cables. The Elementaries circuit connections and relationships of components are all preserved when an Elementaries diagram is included in the project. Elementaries circuits are normally bespoke or hand-designed in CAD. As soon as a circuit becomes repetitive, it is worth considering developing it in Instrument Manager. Elementaries is a rich set of electrical tools and requires a separate demonstration of about an hour. Elementaries, while originally developed for panel layouts as the name implies, is now also used for cable modelling. It enables a user to place intelligent tray, conduits, etc. into a DWG-based 3D model and then calculate cable lengths and cable tray fills, etc. Elementaries preferences are accessible from the Instrument Manager Preferences interface. Elementaries Raceway 3D models are included directly in the Instrument Manager project. Components will appear in the folders such as motors and cables. Raceway, such as conduit and tray, will appear in the folders underneath the cable routing branch in the Instrument Manager tree. Elementaries too requires a separate demonstration. It takes a little under an hour. Hopefully you can see from my presentation that Instrument Manager is highly flexible by design and can help you ensure you have the best design process. To recap, the deliverables are all template driven, so your choice of layout, structure, colours, layers, line types and fonts will all be used to make them. Templates are used for datasheets, loops, hookups, wiring diagrams, reports and schematics, and of course the entire database. As well as being template based, there are hundreds of settings that you can adjust in the EDS preferences. I will summarise a few of the IM preferences. The first tab allows you to customize the columns seen by each user in the user interface. The next tab allows you to filter the tags list and control the display of descendant components under areas and cables. It also addresses file opening and revisions. The next tab allows you to control the interaction with Excel datasheets. The Loops tab allows you to control the production of CAD loop diagrams. This includes the parametrics for auto loop production. The Hookups tab allows you to control the production of CAD hookup diagrams. The Terminal Strips tab allows you to control the production of CAD wiring diagrams and provides access to hundreds of wiring diagram preferences. The Logging tab allows you to set up which events will be logged, for example component creation or deletion, and on which types of components. The Projects tab allows you to do some project configuration and also control revisions. The Project Data tab allows you to input project information for use in your deliverables, for example the customer and contract number. The Routing tab allows you to select a 3D model for route viewing and also provides access to hundreds of cable routing preferences. In summary, Instrument Manager is customizable. It lets you do things your way, not ours. To recap, Instrument Manager provides you with the following features and benefits: a relational database with single source component data, giving a higher level of accuracy and less chance of error or rework. Highly productive and accurate mass production of loop diagrams, datasheets, hookups and wiring diagrams. Automated error checks, user and event logging, and data test highlighting, which all reduce the chance of errors in your project. A template system which ensures that if your master is correct, then your deliverables from that master will also be correct. Catalog specification driven data, again reducing your chance of data errors. Bulk editing systems and external data import systems elevating your accuracy and improving your productivity. All of those accuracy gains are summarised in this diagram. If you are making less errors, you will have less rework and your project will take less time and cost less. Similarly, if your efficiency and productivity are elevated by the Instrument Manager benefits, then your project will be completed faster and cost less. How good is Instrument Manager? Downer Engineering's power business in New South Wales, Australia said, for the Pinjarra Unit 1 gas turbine power station, automatic generation of drawings from database information resulted in significant improvements in terms of drawing accuracy, quality control, and change management.